electrochemical cell, or normally it is also called as a simple cell. So first we will discuss about the what is the cell and what it does and its working. So cell is a device which maintains the flow of current by converting its chemical energy into electrical energy. So we can define like this: it is a device which by converting its chemical energy into electrical maintains the flow of charge, maintains the flow of charge in a circuit. This is the main purpose of a cell. It is a device which by converting its chemical energy into electrical maintains the flow of charge in a circuit. How it does, that we would like to see here. First, see the construction diagram of a cell. So in the cell we are having two electrodes. Let this be one of the electrode and this is another electrode, and these two electrodes are filled or immersed in electrolyte solution. So this can be said as a electrolyte solution, and these two are electrodes, and this is the terminal. So one is your positive and negative. So this is the main, you can say, internal diagram, and symbolically we are representing this with a two vertical line. One is your smaller line, another your bigger line. A smaller line indicate lower potential point and bigger line indicate higher potential point. So smaller negative does not indicate here negative potential. Negative indicate your lower potential value. See how the potential develop across the electrode of a cell. So in this electrolyte solution, and there is a electrodes which are made from certain metals. Due to some chemical reaction, a constant force develop between the two electrodes. So we can write here that we are not going to the which type of chemical reaction. Normally oxidation and reduction reactions occurs inside the cell due to certain chemical reaction, that we can say oxidation and reduction. Due to certain chemical reaction inside a cell, a constant force develop between the electrodes of a cell. between the electrodes of a cell. Due to that force, a positive ions of electrolyte solution due to that force, a positive ions of electrolyte solution accumulate at one of the electrode and negative ion on another electrode C. So, due to this chemical reaction occur inside a cell. So, due to that, a constant force that we are writing here Fc, C for constant as well as C for chemical. So, here in one of the electrode, positive ions accumulate. In one of the electrode, positive ion accumulate, and in another electrode, negative ions accumulate. In another electrode, negative ions accumulate, and due to this positive and negative ions accumulation, an electric field established from positive electrode to the negative electrode. So, electrolyte solution, so due to that positive ions accumulate, positive ions of electrolyte solution accumulate at one of the electrode and negative ions on another electrode. Due to this accumulation of charge, a constant electric field established. An electric field established between the electrode electrodes which opposes the positive charge, opposes the force on positive charge due to chemical force, due to chemical reaction, So, initially electric field is less, less than the force due to chemical reaction. Initially electric field is less than the force due to chemical reaction. So, accumulation of charge continue. Accumulation of charge or accumulation of ions continue. At one time, when sufficient amount of charge has been accumulated, sufficient amount of charge has been accumulated so that net force on the ion becomes 0. So that net force on ions is 0. So further drifting of charge stop. Drifting of charge stop, and a constant electric field develop between the electrode, and a constant electric field develop between the electrodes. Okay. So meaning of that, the meaning is that as soon as the system has been made, a cell has been made, a chemical reaction start taking place. Due to that chemical reaction, a force develop, a constant force develop between the electrode, and that constant force pushes the ions from one electrode to another electrode. So due to this force, positive ions start accumulating at one of the electrode. So negative ions will be in the another. So in this positive charge and here negative charge, due to that positive and negative charge and electric field in this direction. Initial the charge on this was less, so electric field was less. So the ions which was coming due to the chemical force, those ions experience one chemical force, another electrical force. But being a less value of electric field, electrical force is less. So further ions continue to reach on the respective electrodes. But as the amount of charge on the respective electrodes increases, so electric field increases. At one stage will come when the electrical force in that direction and chemical force in this direction, these two forces are equal and balance each other. So if we are considering any one of the ion having charge Q, so that ions experience electrical force QE and chemical force FC, and these two are equal. That is called your equilibrium stage. So at equilibrium stage, whatever the electric field, that electric field constant. If the V is the separation between the electrode, so there is a potential difference between the electrode, and that potential difference numerically equal to the EMF of a cell. So we can write like this. So at equilibrium, chemical force is equal to electrical force. So Fc is equal to your Q into E. Fc is equal to Q into E. At that time, a constant, a uniform electric field established between the uniform electric field established between the electrodes if D is the separation between the electrodes. If D is the separation between the electrodes, then a constant potential difference, develop between the electrodes, and that potential difference is given as V is equal to E by D, and numerically the potential difference between the electrodes is equal to EMF of a cell. So, numerically the EMF value and potential difference between the electrodes are equal, but if we are looking for the either these are two are the same thing, those two are not same, little bit difference is there. So, we can say EMF we can define like that. See, the EMF of the cell is defined as the EMF or the electromotive force or EMF of a cell is defined as the work done by a cell, the work done by a cell to bring a unit charge from one electrode to another electrode. So, EMF can be written as EMF is written as work done per unit charge. Now, this EMF work done your chemical force into D by charge as in equilibrium Fc is equal to Q into E. So, EMF E written as QE into D by Q. So, EMF is equal to E into D, and which is equal to potential difference between the electrodes of a cell. This is the meaning of EMF. So, but EMF depends on the chemical force, or that depends on the chemical reaction, but numerical value of EMF could be equal to the potential difference between the electrodes of a cell, but it cannot be said EMF and potential difference are same physical quantity. So, EMF is, so we can say, so EMF is the due to chemical reaction. So, EMF of cell is due to chemical reaction, while potential difference is due to the electric field. While potential difference is due to static electric field. So, this is the difference between the EMF and potential difference. So, this is the point which we can define under electrochemical cell.